looking at another chain rule example in this video. We've got u, you could call this variable anything, but use some function of x, y and z. So the key to take from that is it's a function of 3 variables, and these variables are functions of alpha and beta. Alright, and we want to find the partial derivative for u with respect to alpha and beta, so that's what we're going to look at the chain rules for. So partial du by d alpha, we'll look at that first. And seeing this is a function of 3 variables, we're going to get 3 terms in our chain rule. So we get partial du dx by partial dx d alpha plus partial du dy partial dy d alpha plus partial du dz d alpha. Alright, and that follows the exact same pattern as last time. It's just that because u is a function of 3 variables, we've got 3 terms. Alright, so hopefully by now, if you've watched last video and this one, you're seeing the pattern. And to know how many terms you need, you just need to see how many variables you've got for the thing you're differentiating. And partial du, the beta is defined very similarly. It's partial du dx partial dx d beta plus partial du dy partial dy d beta plus partial du dz partial dz d beta. And that concludes this example. So hopefully it's starting to see the pattern. We've got a couple more examples of different situations we have, and just subtly different, but the pattern and the rule is always the same. This pattern of differentiation partly with what you can here, so u with respect to x, y and z, and then for each of when differentiating with respect to x, multiplying that by partial dx by the variable you want to differentiate u by. So it's always d alpha in this case, or here we're looking at d beta. Okay, so pretty simple rule. If you just write these down or go over them a couple of times, I'm sure you'll remember them quickly. If you did enjoy this video, please like and subscribe, and I hope to see you in the next one.